here we have the same force that we've calculated previously, and that force occurs at the 0.7 meters, 5 meters. Now, this is not labeled particularly well. This point is A, this point is B. So I'm going to make this a little more clear. Here's your force F, and this point here is the point A. This point here is the point B, and this vector is the delta S vector. And the delta S vector is 0.1 meters times I plus 0.4 meters times J. Now, the question is, what's the work required to move this charge at this point? Remember, that was a 6 microcoulomb charge from point A to point B. And the answer is fairly simple. The work is force dot the displacement. Okay, so now we're making an implicit assumption here. This is a fairly small displacement. The force is actually going to change a little bit from here to here because the vector R12 from our original point out to here is going to change slightly, and the distance is going to from that point is going to change slightly. But you're not going to get a real big change, so we're just going to approximate this, assuming that the force doesn't change between this point and this point, even though it actually does. We could accommodate that by doing a line integral, but we're not going to do that, at least not yet. So the work is F dot delta S. So we do the dot product of the force vector with the displacement vector, and we get, I'm not going to read it to you, we get 0.00066 joules. You should verify that. So now the next question is, what's the work per unit charge at the 7 meter, 5 meter point, meaning the charge is at the 7 meter, 5 meter position. That's the 6 microcoulomb charge. So we divide the work by the charge, and we get, I believe, 11 volts. 11 joules per coulomb, and that means 11 volts. A volt is a joule per coulomb. It's a measure of how much work it takes to move charge, a given charge, from one point to another. That's the work per coulomb to move charge from point A to point B. So we're going to say that that quotient, the delta W over Q, and I might even make that more explicit by calling this Q2, the delta W over Q2 is the voltage between A and B, okay? And that's, again, the meaning of voltage, and we'll build on that in the next class.